Hi everybody, welcome to the downstream processing in biotechnology lecture. Okay, previously we talked about the characteristic of bioproduct, but in this lecture we will talk about the characteristic of the bioseparation process. What bioseparation characteristic? There are at least 6 features that we will consider when we select which separation method is preferred for the separate bioproduct. It may be depend on the different property, physical property, chemical property, thermal property of the bioproduct that we separate from the medium component. And the first one, for example, like the activity. Activity is a more primary and secondary metabolite are unified by chemical composition and structure that are confinable by precise analytical method. So this is we talk about the activity, for example, like enzyme, yeast, something like this. This product we use to characterize the reaction. That's mean we talk about the activity. The activity property is really important. Which kind of method we will use to separate this product? And also after separate, the activity still works. And the second one, the complexity. The complexity is based on the product from the fermentation. After your fermentation, we get fermentation board. In fermentation, we get a lot of components, like solid, liquid, gas mixed together. And also this side product also mixed together. How to separate it based on the complexity. And the third one we talk about reliability. Reliability. This talk about the property or the condition that affect to the bioproduct. It's maybe the fetching, maybe the temperature, maybe the solvent, maybe the chemical, mechanical strength, something like that. Is it? It means the bond energy, it maintains native configuration, reaction rate of enzyme, and etc. For example, like small molecules, small organic molecule, alcohol, ketone, acid. This can be maintained by high energy covalent bond, can resist substance variation in the molecular state. That's how to break the bond of this. What method should we use? We have to consider this also. And in order the condition, we have to control the condition of the solution like pH, like our display, like temperature, and the suppression of enzyme reaction. Understand? And in order, like for example, surfactant, organic solvent, like mostly we use this solvent or surfactant to disrupt the hydrophobic bond. That's why we use it to release of the cell, that you disrupt the cell, and then we get protein release from the cell. And another, for example, like fluid, solid, or gas, liquid interface. This interface can absorb dissolved biopolymer, maybe unfold inactive aggregate biopolymer. That's right. Sometimes when it's based on the mechanical situation. What do we use mechanical to disrupt the cell? When you use mechanical, maybe affect right interface. This is, for example, right. The first is a process scale. If we would like to separate bioproduct from the mixture, we have to consider like process scale. For example, a small primary metabolite, alcohol, acetic acid, something like this, maybe commodity chemical with market demand of 10 per year. The scale should be large. That's right. The scale should be large. And another we have to check the market requirement. For a like a bioproduct protein, in particular, like typically 1 to 10 kilograms per year in animal. This is a small scale for that scale. For example, like Chinese hamster or CSO cell, E. coli, bacteria, yeast, CSO agriculture impact 8,000 to 25,000 liters. This also is small scale production. We compare to the family metabolite acetone and choline market is a large scale. And another example, like antibiotics also is small scale, where we may produce 1 kilogram per year, something like this. Okay, the due to the initially low concentration of bioproduct in aqueous fermentation and cell culture feed or dissolved in excess water, which is removed early in the bioprocess to reduce equipment size and improve process condition. Okay. In this, we talk about the process secure. The process secure is depend on the market demand and depend on the initial concentration in the product. Okay. In purity, the bioproduct purity is if we talk about the food and drug product, okay, purity is very important. Very important. Yeah. For example, like the mass of the host cell protein, with the protein DNA, endotoxin, and membrane, something like this. As a limit, we have to check the purity. Particularly in the pharmaceutical industry and food industry, the purity is very important. As well. For this case, we have the institute to control the purity, like Center for Biology, Evaluation and Research, Food Drug Administration or FDA. I think this institute to check the purity, to set up the specification of purity. If you would like to produce this product, you have to control, to purify until get the standard, until meet the standard of FDA, CBER, something like this, and also WHO, World Health Organization, also to check this. Okay, how to check the purity? The sterilization of the final product is ensure sterilization filtration. It is the final product to ensure that it is purity or not. This step. And approval and manufacturing. And the last one we have to check, especially when you produce like food and pharmaceutical product, the process should be improved. The process should be improved. For this case, FDA will be ensure like the safety and efficacy of the bioproduct used in human diagnostic, prophylactic, and therapeutic application. Okay, this is for the diagnostic การวิจัยโรค prophylactic การป้องกันโรค and therapeutic การรักษาโรค This is important. The product for this application we have to carefully check from the start until the final product. Okay, the process should be approved also for this case. What if we talk about this? We talk about the GMP or current GMP, current good manufacturing practice. For this case, we will check right the design of the process, layout of the factory, equipment, and process in good operation, cleaning, sterilization. You have to check, you have to approve this before you produce this product. That's right. Okay. For the next topic, we talk about the bioseparation synthesis. We have a lot of techniques, a lot of steps to separate. The bioprocess are required to economically and reliably purify products from chemical, biological species in complex cell matrix. Sample cell particularly, you have to recover the state. If we back to like the fermentation, after you ferment, we get like the fermentation board. In fermentation board, there are lots of components mixed together, like solid. Solid means the several particulates or cell, yeast, bacteria, something like this. You have to recover it also. Maybe recover by sedimentation or filtration. Another problem is biopolymer. Maybe we have usually purified by filtration, absorption, extraction, and precipitation. It is the kind of bioseparation. We will talk usually later. Small molecules like acetone, alcohol are often recovered by extraction. This is for example. For this, we have to consider like the economic value engineer. The economic is very important to consider. The documentation like the approval process by FDA, something like this. You have to consider the genetic engineering. Also, this we have to consider when you produce the bioproduct. It's very important. Okay, the first step, the bioprocess economy. the bioprocess economic is large-scale economic operation must be efficient. When you produce the bioproduct, we have lots of steps. Right? The first step is the latent step. You change the raw material to be the product. And the next step, after you get the product, it's in the mixture, you have to separate. The more economic cost, it depends on the downstream processing or separation process. That's that. Since the cost is looking, it's cost based, recording biomolecule are treated with organic solid waste can determine the maximum cost. That's that. The cost of equipment, the cost of waste treatment, the cost of chemical used in the separation process is also considered is a cost. That's right. It's quite important to consider. For example, right, the development of a typical pharmaceutical bioproduct cost is maybe $400 million in 1996 and requires 14 years or 6 years from initial discovery to preclinical testing and another 7.5 years for clinical trial in human volunteer. What does it mean? It's normal, right, when you talk about the COVID-19. COVID-19 it's a long time to create like the vaccine because the time consuming in like the step of this step, we have to test. When you produce drug or you get the vaccine, we have to test by preclinical test, and another we have to test by human volunteer for the clinical test. Yes, when we can discover the vaccine, but you have to wait until preclinical test is okay, and then you test in the clinical test by human volunteer. After the clinical test is good, result okay, we can produce this for the world, for the people. We can use the vaccine for COVID-19. That's we make time consuming. And also the time consuming the cost also. That's that. If some drug, if some product, the time consuming is long time, the cost should be high. If some product is the less time, okay, the cost will be low. It depends on time also. That's that. Not only depend on the equipment, depend on the chemical. It depends on the chemical equipment, the time of development, the time for research and development is also it depends on all this. The documentation, I talked to you already, documentation is very important when the product is about the pharmaceutical and food product. TCMP is very important. The good management practice, the process is safety, the process is safe, the process is clean. This process should be approved by the FDA or CBER or another. In Thailand, this is oil. Okay. And another, right, the model biotechnology, like genetic engineering, we have to consider like this. Okay. The next step, we talk about the bioseparation step. A general sequence of biorecovery step is designed to remove solvent, remove insoluble right, solid particulate removal, unrelated soluble species, and similar species. Yes, and for this case, we may be separate, classified in about 3 or 4 or 5 steps, right? Fraction, clarification, concentration, fractionation, and purification. And we talk to you the next slide. But for this slide, we talk how to confirm, how to characterize with each step is okay or not. Mostly we talk about the purity, activity, and yield. The purity, if we calculate the purity of our product, that's that. We check it's good or not. It's meet the purity based on FDA or not. That's that. The yield, high yield or low yield. The yield is very important for the economic consider. Purity is important to meet the expectation, meet the FDA, meet the food and drug process. But the yield is important to what is the percent that you can convert raw material to the product. That it also depends on the step. Right? It's Also, very important to learn the economy. Okay, what is purity? The purity is the bioproduct mass divided the bioproduct mass plus the impurity mass. What does it mean that, okay, we have the raw material of feed. Okay, we have to know how many products in the mixture. This we call it the bioproduct mass plus impurity. And then you get purity. Okay. For example, after you separate many steps from sedimentation, filtration, certification, extraction, absorption, you get the final product. And then you check this product. If impurity is 100, that means there is no impurity. If it is not 100, it's 90, that means 90% is biomass and 1% impurity. This is purity. And the second one, activity. Activity. Maybe we talk about the unit of enzyme, unit of yeast, means mass of enzyme, mass of yeast. It equal to the unit of biological activity by the bioproduct. That's right. Mostly the unit of biological activity, we talk about unit of enzyme, mass of enzyme, something like this. And the last one is the yield. Yield equal to bioproduct mass recovered divided by bioproduct mass in the field. What does it mean? Is we would like to check what percent, how many percent that you can convert feed or raw material to be the product. If the yield is 90%, or the yield is 0.9, something like this. Its fraction is 0.9. In percent, it's 90%. That means it's 90 mass of product you can recover, and 10 you cannot recover. That's an effect on 100%. This is the meaning of it. This also equal to the economic for the yield. That's right. Okay. For this show you the example of the bioseparation step. We have lots of steps, right? For example, like the homogenization. Homogenization equipment you disrupt the cell. When after you disrupt the cell, like the biomolecule, the substance will be released from the cell. For this case, the purpose we have to extract target from the cell. We have to extract the chemical, the biomolecule from the cell. The second step, like fluid solid separation. As this may be flocculation, precipitation, crystallization, extraction, something like it. The fluid solid separation, we would like to reduce the volume to clarify the target species. That we can remove like the culture media, remove the fermentation board, remove the host cell DB, or remove the application, something like that. And the third step, solute separation. Solute separation. After the second step, we separate solid. The remaining is liquid, for example. You can remove solute. For example, it's maybe we would like to remove unreacted solute, small molecule, protein, lipid, nucleic acid, something like that. We can use chromatography, extraction, crystallization, for example. Okay, the purpose to use to fractionate, you have fractionate what means to separate in the fraction or purify the target species. And the next one is fluid solid separation. Fluid solid separation. For this case, this means that we can separate the solid that in form of solution. It is the liquid, but in the liquid there are some substance dissolved in liquid. For this case, we can separate solid like precipitation, like crystallization, like filtration, by evaporation or drying. For this case, we use like to formulate or polishing to preserve. We would like to remove buffer or solution for this case. For example, is for like sugar, right, or syrup. In syrup, we have water and solid. Water and sugar, but sugar in terms of liquid, because the sugar dissolved in liquid. You can separate sugar from liquid by crystallization, by evaporation, and then we get the solid sugar out of the liquid. This is the step of fluid solid separation. Okay, because the first step is extraction. The extraction for the first step, we would like to extract the biomolecule from the cell. from the cell. Okay. For this case, we extract the biological species from this cell is by homogenization. It renders the product soluble and liquid, solid, and solute separation. Okay. For this case, we use the homogenizer to break the cell, to disrupt the cell, and then the cell will release some substance, some chemical, and then you have to separate the next step. After you break the cell, we have at least two components, solid and liquid. The next step, you have to separate solid liquid, like the next step. This step. Clarification. Clarification, we utilize to separate solid from liquid. The solid is cell liquid. So liquid means a small, very small cell after you break the cell. You have to separate cell nucleus, to separate nucleic acid, to separate protein from the mixture. It can be separated by centrifugation, by precipitation, by membrane, something like this. For this, the precipitation maybe you can affect by adding salt, adding organic solvent, adding detergent or polymer. For this, we will talk to you later in precipitation process. And then also we can use the membrane to separate solid liquid, which may be microfiltration, ultrafiltration, something like that. To use the cell to beat out of the liquid. And after the extraction, clarification, and then you have to concentration. In your product, after you separate liquid of the solid, separate solid of the liquid, the mostly product in terms of liquid is maybe solute, solvent, dissolved together. You have to separate solute, maybe solute in our product. We have to separate the solute. But our solute is very, very small volume. You have to concentrate this. You have to concentrate it by remove some solute, by remove some solvent out of the that's right. Okay. It's maybe you can use this by extraction. That's why you can extraction of some solute out of the media. That's right. Or solvent removal. You can remove solvent, you can remove solute, because in the liquid phase maybe more than one solute. In solute, only one is product. That's how you can remove another solute, remove solvent by extraction. Or another you can use the diafiltration. That's diafiltration. This is the membrane, another membrane technique to separate liquid solid. Okay. Another technique we can use like the adsorption. The adsorption, we can adsorb some molecule to the surface, and some molecule cannot adsorb. Something like you can separate. Microfiltration also we can do. Okay, for this equipment we talk to you later. Each equipment. That's that. The next step is fractionation. Fractionation of the target product usually on one or more complementary separation process to distinguish between product and the uncontaminated. What does this mean? The fractionation we have to separate product and contaminant. Maybe you use filtration, adsorption, and maybe you separate and maybe like adsorption, and also you can use like isoelectric point, charge density, and hydrophobicity, something like that. This is based on the characteristic of the. Okay, due to the high specific adsorption, we can use adsorption for this change. Adsorption, there are a lot of kind of adsorption, maybe affinity adsorption, ionic chain, hydrophobic interaction, reverse phase adsorption. We will talk to you later also. Okay, for the function of fractionation is used to separate between contamination and product. That's right. After you separate contamination and product, and then your product, you have to purification of product. Purification of product is the concentrated and fractionated product from closely related variant occurred by high resolution technique. This is the final step to get the purification. Mostly the purification requires different adsorption let's say maybe absorption, maybe polarization, you can use, or maybe electrophoresis technique. And photofluorescence causing. This is we have like a lot of techniques to purification like absorption, polarization, electrophoresis. We study all of this in this class. All this in this class. The last one. But some product, after you purify, okay, there are many to formulate some product. Especially for the pharmaceutical product, we have to be the dosage form, the solid form, the dosage form, we have to change the treatment to be the tablet, something like that. This is the formulation or polishing technique. Such as for pharmaceutical product, after you get the purified active pharmaceutical ingredient, is maybe you would like to form the tablet. You have to add some excipient such as stabilizer. You use the stabilizer to reduce compound like polymer, tablet, solid, and gum, PEG, or oil, and like water, something like that, to add mix together, and then you get the top result. This is the final step for formulation. Okay. In conclusion, we have four steps for the downstream processing. The first one, we would like to remove or insoluble discontinued extraction and clarification. Extraction, we remove solid form liquid after you dissolve, and then you clarify by separate solid form liquid. And the next step we call is isolation of product. For this case, we use to concentrate and fractionate the product. After you concentrate and fractionate the product, you get higher concentration of the product, and then you purify, and finally you formulate formulation. I give you an example of the production of bioprocess production. This is the ethanol production. The first step, after you ferment that fermentation, and then this step is the downstream processing. We talk this in this class. After you fermentation, you get the fermentation board, but also the beer or alcohol mixed together in this. There are solid, liquid, some gas mixed together. And then you have to separate. Right. Beer still is maybe the distillation, you get condensate, and you get solid, that's right. And then solid strain this heat by filtration. Then you gain dry soluble. You have some liquid from dry get it, and solid get it. And liquid that out of at top of the column, you get the condensate, you get whiskey. That's right. Something like that is the process for the ethanol production. In the citric acid production, the first step you have to fermentation. After fermentation, you have changed the raw material to be the product. After you get product, there are some component mix solid liquid can separate by filter. And the filter you can separate solid out the citric. And then the liquid you send to another, let's say the lump solid to precipitation. After the precipitation, the solid that dissolve the liquid, setting out, and then you filter again. Then sulfuric acid, right? You get the solid and then you filter again. Right? This is solid, looks solid and solid. And then you send to the carbon to absorb something and filter. And evaporation, centrifuge, drying, you get the solid citric acid in the solid form. Dry to dry, remove the water or remove the liquid. And then evaporation, catalyzer, evaporate some liquid, you get some solid, and then you centrifuge to separate solid liquid. This is example of the bioprocess. Okay, for this case, you can classify in the step that I talked to you about. We have four steps: removal of soluble, isolation of product, and product purification and product processing. That are upstream processing reaction. After reaction, biological reaction, there are some mixture. Right? The first step you have to remove insoluble. This means the solid. You have to remove step. You have to remove bacteria after you ferment it. For this case, we remove enzyme. That's right, enzyme by the disruption. Right? After you disruption by solvent, you add the solvent, right? The solvent you disrupt, enzyme release of the solvent, and then you can remove the TB by this. Okay, you can remove the TB solid, remove out, you get liquid, only the liquid. In the liquid, there are some solute dissolved in liquid. You can separate the solute by precipitation. After you precipitation, there are some solid precipitate of the system. And also you go to the precipitation, you get the solid and liquid, you send to the next filtration, separate liquid and solid. And then another liquid, you have to remove some solute by chromatography. You get pure product. And finally, you have to product polishing, right? You get precipitation again. Precipitation again. What a precipitation again, we would like to separate solids out of the solution. You get solid and liquid. And then you change, separate again by dielectric or membrane. And centrifuge, you get solid and liquid separate. And then you freeze dry in the solid. This is the most of the step that we talk about. The first step, right? Removal of soluble, isolation of product filtration, and product polishing. Removal of soluble, we separate solid of the liquid after you dissolve. And then you remove some solute from the contaminant by isolation product. It may be clarification, it may be extraction, absorption, chromatography, and product filtration. And the last one is polishing. Okay, this is another example, right? Bioprocess production, right? It is the penicillin production. The first step you have to ferment it. That's right. Filtrate. That's right. You have lots of things in the same. That's right. This is reaction. This is separation. You get biomass out of the system. You add the acid, add the solvent, and then you get extraction. And then liquid. By stripping technique, you get the waste solvent, and at the acid, you get the extraction, waste water. The stripping again, waste solvent, and then you ketoride. You get the product at the solid form, and dry in to remove the water. Something like that. You get the final product in the solid form of the penicillin, for example. Okay. The last consider, we would like to talk about basic question. What change can be expected to occur? How fast will be the process take place? How can the system be operated and controlled to maximize yield? How can the product be supplied with maximum purity in non-cost? Okay. What change can be expected to occur? You have to know what is your product and what is your process. If your product is maybe the extracellular product, it's not necessary to be the disruption. You can only separate the cell out of the solution, and then you can do clarify, you can do purification and polishing. And the next step, how fast the process takes place. This is depend on the contamination. If the contamination is low, it may be fast to finish the process, get the product. If the contaminant or the component mixture after fermentation is high, okay, you need long time for that. How can the system can be operated and controlled for the maximum? You have to control like this. It depends on the property of product, the property of contamination, the equipment that we use. Okay. How can the product be separated with maximum purity and maximum minimum cost? It's very important for engineer. You have to minimize cost, but also you have to maximize purity. It's dependent on a lot of the factor, the limitation, the process, the characteristic of process, the characteristic of bioproduct, the characteristic of contamination. That's right. This is the advantage of bioprocess. Why we talk about the like to produce molecular alcohol, you can produce alcohol from physicochemical plant. And also you can produce alcohol from the bioproduct. But what is the advantage of it? The first one is mild reaction condition. If you produce alcohol from the physicochemical plant, okay, it may be high chemical, high corrosion. as a high pressure, high temperature, or low or high, something like that. But for the bioprocess, the condition it should be at low temperature, low pressure. That's right. And the bioprocess, we specify in high specify. When specify is high, you get high function, high product. The product is very effectively renewable source. You can use the raw material is a raw material with renewable raw material, right? You can use the biomass. If you compare to the physicochemical, that's that. For the bioprocess, we can use the renewable of the biomass. If you would like to produce the alcohol, you can use the cassava, you can use sugar cane. That's sugar. Cassava sugar cane, 1 year you can produce 2 or 3 times per year. Yes. This is renewable resource. And the technology for recombinant DNA technology, you can use the genetic engineering with the advantage of the bioprocess. Also, there is one thing, but also there are some disadvantages. The first one is complex product mixture. It's the complexity of the phase up to the process. This is the disadvantage. And the third habit is low concentration. The product is low concentration. You need a lot of equipment to separate, to verify. And another is contamination. And the last one is variability. Yes, variability. They show you right. The traditional process is fermentation modified the process for the production of alcohol or lactic acid from glucose. But nowadays, fermentation is an enzymatic controlled transformation of liquid. They show you that the traditional process is alcohol. 1,000 years ago, we know alcohol from the fermentation. Okay, we will stop the lecture today, and the next lecture we will talk about the first equipment that we will consider to separate solid from the liquid. That's like filtration, centrifugation, and the next one we talk about the disruption and the nozzle. Okay, see you for the next